Okay, question 2. How do we make the ester? So we're going from an alcohol to an ester. There's a couple of different ways to do that. One, the Fischer esterification, which is the carboxylic acid and a strong acid. Probably not the best of ideas here because of the acetal. We might end up tearing it right back off again. Again, using sulfuric acid with a structure that's not very simple is something to be approached with caution. So if you see yourself writing that and the structure is more than a few atoms, you should be thinking maybe there's a better way to do this, because that's asking for trouble. Sulfuric acid is the molecular equivalent of a sledgehammer. It's not subtle. So if there's anything else around that can be broken, here's the culprit. So I tend to shy away from that one with stronger structure, with more complex structures. I didn't mark it wrong on your exam, but just for future reference, if there's anything else around, particularly if there are chiral centers, carbonyl groups, protecting groups, that is a really bad choice. So the other esterification methods are, we have the acid chloride, and something as a base like pyridine or triethylamine. So base, so it's an amine base, not like hydroxide. The third method is actually the one used in the synthesis itself, which is to use the anhydride. Now again, this assumes that the anhydride is available and that the carboxylic acid precursor isn't overly expensive, because you are wasting half of it. But it does not have the risk of generating hydrochloric acid as a byproduct the way this does. So this is also probably going to have a base along with it, and that's the way they went about it, which is the anhydride. And probably the safest method here, as long as the acid is not overly expensive. This isn't. This is, isobutyl carboxylic acid or isobutyric acid. So not really something we have to worry about in terms of cost. So if the anhydride is relatively cheap, then you use it. Okay. And again, just so we're clear, here it is. Here's the anhydride. With triethylamine, and this is a coupling agent to kind of help out since that's a slower reaction. But again, this is just an acid anhydride forming an ester. These are simple reactions. Again, the same type of stuff we've learned, same reagents we've talked about, with a base to mop up the leftover carboxylic acid. So that's what the triethylamine is for. Okay, so next part of the question is not related to what they would do, but just to make sure you're paying attention. Why are we not getting an amide here? And the answer is because it's already an amide. The lone pair you would need to use there to make an amide is busy. It's resonating. It's not available. So it's not an amine. That is an amide. So you are not making another amide out of it. It's actually an imide. It's between two carbonyl groups. So you couldn't ask for a less available pair of electrons. It's actually resonating to make that ring aromatic in the first place. But the point is, even if we didn't have a pi bond on the other side where aromaticity wasn't the issue, you still wouldn't be making an amide out of that, because that pair of electrons is resonating into the carbonyl above it, to the left, upper left there.